Welcome students. Today we are going to start with module 4, that is network security. And in this security we are going to learn how the attackers are going to attack on the data, how we are going to prohibit from that attackers, and what all are the algorithms we are going to utilize. The details description about the network security we are going to see now. So moving towards the next slide, here I have some security overview. The first thing you should know about, like, what do you mean by the security, what we are going to learn in this chapter. So here the first thing is security is nothing but whenever you are going to prohibit from some attackers towards your network, that is known as your security. You are going to provide the secureness towards your data or towards your network. So that is nothing but that is known as your security. So here we are going to learn the principles of your network security, how exactly it is going to work out, and also we will learn some of the cryptography concepts in which there will be some security services, that is known as your confidentiality, integrity, and availability. So all these things we are going to learn under your cryptography. And also we are going to check it out, the authentication power, how we are going to authenticate. If we have given the authentication, how we can access the data. And also one more thing, that is message integrity, how we can keep the unique message in our network and no one can access the network without any kind of your authentication. So these are some of the principles of network security which we are going to discuss in this chapter. With that also we have some of the other things, that is known as your security in practice. Okay, so in this security in practice we are going to find out the firewalls and the intrusion detection system, how we can place all these things inside the network and we can give the secureness to the network. And also we will see the layers, how the security we can provide in our layers in the sense, we have OSI layers. There are 7 layers: physical layer, data link, and then session layers, then presentation layers, and the last one will be your application layers. So we are going to work out, we are going to provide all the security for these layers. How we are going to provide that also we are going to check it out in this chapter. Now moving towards your outline, first we will go through the network security. So now what is network security? So here you can see the network security in the sense, I told you there will be some of the network services which we are going to provide. The first one will be your confidentiality, okay, and the next one will be your integrity, and the next one will be your availability. So here discussing about your confidentiality, we have you have to remember always two things in your network. One will be sender, another one will be receiver. The sender will send the message and the receiver are going to receive the message. So while sending the message from sender to the receiver, no one should encrypt, no one should attack on the message whatever we are sending. So whenever we will send the message, we have to encrypt the message, okay. And whenever we in the receiver end, whenever the message will reach, the receiver has to decrypt the message. So once we have given this encryption and decryption techniques, no one can hack our data or message whatever we have sent from the source to destination node. So here we have to take care of all these mechanisms. How we are going to take off all these mechanisms, how we are going to take care, these things we are going to take care by applying some of the algorithms. That algorithms I told you, that is DES algorithm, AES algorithm, RSA algorithm, Diffie-Hellman exchange algorithm. So we are going to utilize all these algorithms for providing the confidentiality towards your network security. So now the next one you can see, authentication. What do you mean by authentication? Here we have to authentication in the sense you are identifying someone who can access the data or through whom you can share the keys or some of the secret data. So that is nothing but that can be happen in between two people, that can be your sender, that can be your receiver. So now sender and receiver, if they want to confirm the identity of each other, they can confirm to each other. Okay. The sender can share the secret values to the receiver and the receiver also can share the secret values to sender. So whenever the sender will share the secret values, it will be the private data to your receiver because only sender is sending to the receiver. So whenever receiver will send the data, any secret values to sender, then that particular data will be the private data for your receiver. So that is known as your authentication. Next one, I told you that it can be your integrity. So integrity, for whom we are going to provide the integrity, it can be your message integrity. So in this message integrity, what exactly we are going to do, there will be the sender and receiver who wants to share the message in between them. So whenever we will share any kind of your message, the message cannot be altered, or it cannot be deleted, or it cannot be transited, or anything, any alterations cannot be happen inside that message whenever we are sending from your sender side to the receiver side. So if anything happens in that, then we can say that the message is not integral, or the security has not been provided towards the message. So you need to detect any of the, if any of the errors are there or anything happens, so it has to be detected for this integrity portions. So the next one, I have told you that availability. So that is nothing but your access and availability, where the services can be accessible, or how you are going to be available for your users, that you are going to provide in this network security. So now here you can see one of the diagram. Here the friends and enemies are there. Some fun kind of lines over here are present over here. It is directly from your book, so I think you can have the look into this. You can see there are two persons. Okay, so now here this side it is Alice and this side Bob. So now what happens in this, this is the sender side and this is the receiver side. Now Alice wants to communicate to the with the Bob. So now what she has to do, she has to send the message from this side to that side. Okay, so this is my source or sender, and this is my destination, or you can say that that is my receiver end. So now what will happen? Here the Alice will send the data by using the secure sender side, and the Bob will receive the data by using the secure receiver. So through which media it is going to send? We know that if we are connecting any of the nodes, that node is nothing but it is going to connect by using the coaxial cables or physical medium. That coaxial cable or physical medium is also known as your link in between sender to the receiver. Okay, and also that link known as your channels, where the channels, through that channels, the data, and there will be the control of the message. But suppose if any of, so here what happened, the Alice is going to send the message to the Bob. Okay, so by using the secure channel. Now who is this person? This Trudy is there. So who is he is a introducer. So what he is going to do, he is going to intercept or delete or add some extra messages while sending through this secure channel. If the channel is not secured, then he can or she can add any kind of message, or can intercept the message, or can delete the message while sending from one place to another place. So here we have three. You can say that this is A, this is B, and this is C, and all these people are going to send a message, and this person is going to hack the message or wants to delete the message. So that's the reason they're known as the introducer. Moving towards the next slide, here you can see what are the things we are going to use whenever we are going to send the message from one place to another place. So here whenever we are doing any kind of our transactions, that time we have to use the web browser or server, that already you know. If you are going to use the online purchase, or you are using Amazon or Flipkart, that time you need to use the web browsers or servers if you want to send any of the, if you want to communicate with any of the electronic transactions. And also while payment time, you need to use the online banking, so that time you have to use the client and server methods. So in that time what will happen, the client will send a request to the bank for the transactions, and the server will reply back with a response or acknowledgement. Then the client can proceed with the banking transactions. So while doing all these things, there will be a DNS server. What is the work of your DNS server? This DNS is nothing but that is known as your domain name system. So in this domain name system, in this DNS server, there will be some IP address, and they are going to check it out, that IP address, and by using that address they are going to send the data. And also there will be one more routers which is going to exchange through the routing tables. So what is that? That is my, I have even used here the BGP. that is known as your border gateway protocols. Okay, so this is border gateway protocol. This is a router which is going to utilize or exchange, which will help to exchange the data from sender to the receiver side. And also there will be a table, and because everything whatever we will do, the routers work, everyone will be having the forwarding table. So there will be one BGP forwarding table. So here it can save all the data and the updations while sending the data from source to destination side. So now moving towards the next slide. So now here one case study is there, just to understand the concept about the how we are going to send a message. So now you can say that suppose Alice wants to send a message to Bob. So now in that, while sending the message, some of the things which has a prohibition which can occur while sending the message from one place to another place. So the first you can say that that is known as Eva's drop. What is the meaning of this, what it is going to do? So here the message can be intercepted. Okay, so the message can be intercepted while sending from source to destination. And one more will be there, it can be actively inserted some messages into the connections. It means that there will be one third party who is going to send the message, or who is going to insert the message while sending the message from A to B. The C can send or insert some of the message into that, and they can send the message towards your B. So one more way is also there, that is impersonation. It is a spoof. What is your meaning of your spoof? Normally this spoofing is nothing but it will be useful for your email address. Whenever we are going to send some email, sometimes what will happen, we can send the email to the particular address. Okay, so that time all the mails, what it is going to do, it will be in one of the cache memory. Okay, which one that why it used to happen, because sometimes the email address will be wrong, or sometimes the IP address will be wrong, sometimes the host address will be wrong. Due to all the problems, it can keep all the mails inside one of the cache memory. That is nothing but that is known as your spoof. So here all the fake things can be there. Okay, it can be usable also, it cannot be usable also, that depends upon it. So this is that also you have to remember, this is also one more kind of your spoofing. One more also problem can be happen, that is your hijacking. What is your meaning of your hijacking? Hijacking in the sense you are going to take over, right? So if you have some ongoing connections by removing the sender or receiver, or if you are inserting anything inside the place and all, so that time it can go for your takeover, or you can say that that is your hijacking, when you are going to remove the sender or receiver's connection. One more, the last option is like that, that is one more point, that is your denial of services, which can prevent all your services from being used by the others. It means that whenever we are sharing any of the data or anything, it can be prevent the service, because it can say that my resources has been overloaded and I cannot forward your packets, or I cannot forward your message. So that is nothing but that is known as your denial of service, where they are going to deny that we cannot accept your services, or we cannot accept your messages. So that kind of denial of service always it used to come from the destination side. So now we will see the next concept, that is principles of cryptography. Till now we have understood the network security. Now we will see what are the principles of cryptography. So now this is very important, because you are going to get the question like what do you mean by cryptography and how you are going to work out with that. So this is very important, you please look into this. So whenever the Alice or any of the person, the source side, they are going to send a message towards the destination side. So whenever the message will come, that is known as our plain text. Okay, so what we are going to do, first we are going to forward the plain text. Okay, that is nothing but message, or you can say that that is my aim. Okay, so whenever we will send the plain text, we want to secure our message. So when I want to secure my message, I have to add some encryption key. So this is my key. It means that I'm going to lock my message. Okay, that is the reason I'm going to lock it. So I have this key to lock my message. So here what will happen? I have to apply the algorithm. How I can lock it? So by utilizing this algorithm, I can lock my message. So whenever I will send that one by using the secure channel, the message will be turned into the ciphertext. Okay, so plain text I have sent, but by using this algorithm and secure key, it became ciphertext. Now the ciphertext has been sent towards your destination side. So now the ciphertext, how it can be a plain text? Here we have to use one more key because we have to open the message. So we have to use the key, that is secret key, which has been already shared with your like a source side, and we are going to use a decryption algorithm. By using this decryption algorithm, now the ciphertext can be changed to your plain text. But when I have shared the message from my sender to receiver, here the intruder can text place, the role can be text place, and they can exchange or alter my message over here. If the message, the ciphertext is not properly encrypted, then it can be decrypted also. Like if they have anything, they can decrypt the message. So here only we have to apply the algorithm, and we are going to secure the message. That's the reason encryption algorithm and decryption algorithm I have been utilized it. So now here you can see this aim is nothing but it is my plain text message. So here KA of aim is whatever, this is my KA, this is my plain text, means it is my aim. So here whenever I will get the output, it can be my KAM. Okay, so here this is my ciphertext. Now what I want again, I want to decrypt my ciphertext message. So here what I'm going to do is that K of M already it is there. So I have to apply with this secret key, that is my KB, and I will get the plain text back, that is my message M. So in this way, I'm going to get the message back. So now moving towards your next slide. Here you can see how we are going to break the encryption scheme. So here we have some of the approaches. That is, the first one is like ciphertext only attack. So the attacker can attack only on the ciphertext. I told you here that there will be the intruder who is going to attack only on the ciphertext. They cannot attack on plain text because in the plain text time it will be with the sender. So here there will be two approaches. The first approach will be like brute force attack. This is a concept, and one more will be statistical analysis. So here these two attack will help to search all the keys, the secret keys, through which we can find out that the attack can, the who is the attacker and how to save, how to secure our data. And one more thing will be if there will be known plain text attack. It means that if the intruder has plain text corresponding to your ciphertext, it means that if already they know that what will be the plain text, then it is like a known plain text which has been already not secured before sending the data. So that can thing, or that kind of message also can be attacked by the attackers. And chosen plain text attack is nothing but where there will be the ciphertext, but from the ciphertext you can find out the plain text. So that is nothing but that is known as your chosen plain text attack. So now here we have symmetric key cryptography, the same concept whatever we have sent. So here I have written KA and KB. Here I have written symmetric key because we have two concept of key. One is symmetric key, one is asymmetric key. We are discussing about symmetric key. So similarly, plain text, the message I have sent, here my encryption algorithm I'm going to apply with the secret key or symmetric key. I got the ciphertext. Okay, so by using what I got, by using this KS secret key and also the plain text, that is my M message. So now utilizing this is my ciphertext. Now I want my plain text back. So I'm going to forward it to my decryption algorithm. Here I'm going to use this KS, and with that, so by using that, I will get my plain text back. So here, after knowing all these things, this is a method where we can utilize the symmetric key cryptography to get the plain text back. Now here you can see the simple encryption scheme where we are going to utilize substitution cipher. Okay, you have to remember this because sometimes in the exam they will ask you that by using substitution cipher, convert the plain text into ciphertext. So how you are going to do? You remember first plain text in the sense just you write down A B C D till Z. Okay, then what you are going to do? See, this is the example. Plain text is Bob, how are you? Okay, Alice to Alice. Bob is asking to Alice, how are you? So what you are going to do? You are going to convert by using the substitution cipher. You are going to convert into the cipher text. So first you have to write down in the rough or there itself the plain text A B C D till Z. You just write it down. Then the cipher text you are going to change. Remember, you have to start with MN. Okay. So you can write anything here. It is not mandatory that this line only you have to remember. It's not like that. Just you can write MNOPQRST, then again you start with the ABCD, okay, so that it won't be repeated. You can write, then whatever the name has been written here, you have to just replace it. B has been replaced with N. You can see B has been replaced with N. So that will be my cipher text. Okay, we can map with all the 26 letters with another 20 set of 26 letters, where my plain text can be converted with the cipher text by using this encryption key. Okay, so that you can write here whatever you want to write, you just write. Don't no need to remember this. So you have to just write down this and just convert anything you write, but don't repeat the letters, and then you convert. So that is known as a substitution cipher. Now the next one you can see here, more sophisticated encryption approach. So what is this sophisticated encryption approach? Here you can see I have, suppose, n substitution ciphers. Okay, n substitution ciphers in the sense I have the message starting from M1 to M1 comma M2 till Mn. So this is my substitution ciphers for your message. So suppose I have cycling patterns. I have n equals to 4. So what I can do, I'll just write down any 4 combinations. Okay, again I can have any 4 combinations. So that is nothing but my cycling pattern. This is just to know. There is nothing to remember here. You have to know all these things, how to utilize the subsequent substitution patterns in a cyclic pattern. So whatever it will be there, suppose M1, M2, M3, M4. So you have written M1, M2, M3, M4. Next again pattern you can write M2, M3, M4, M5. Okay, so that what will happen, the last one again will connect with the first one. So it is nothing but it is like your substitution patterns. So here you can see the symmetry key cryptography, that is the first one is your DES. So DES and AES can come for your 5 marks question. So what is the full form of your DES? That is nothing but data encryption standard. Okay, the full form of DES is data encryption standard, which has been started in 1993. Okay, so it takes 64-bit plain text input. Okay, whenever we are sending any message from the sender side, it will accept only 64 bits of data. It will not accept more than that. Okay, whenever we will send any of the plain text, one more thing, we are going to pass the key, right? You have remembered the plain text and the message key, we are going symmetric key, we are going to send. So here the symmetric key, it can accept only 56 bits of data, not more than that. Then what we are going to do, it is going to work for your block cipher with cipher block chaining. Cipher block chaining in the sense, blocks in the sense, in the first time, you can see this diagram. Okay, this is one block. Whenever we have done this thing, this is like your one block. The next block will be connected from here itself. Okay, whenever the plain text has come, again it is going to be the input for your next block. So if I will connect like that n kinds of your block cipher, so that is known as my block cipher chaining system. So one block is like one message you have sent, again connected, and again you got back the plain text. That plain text will be the input for your next block. So in that way, you can get the block ciphers with your cipher block chaining. So how much secure it can be? Because as we are sending the 56-bit key encrypted phrase, so we can decrypt all these things by using the brute force algorithm and also by using the analytical attack. And also this is one more, the next advanced version of your DES is nothing but 3DES. That is encrypt 3 times with 3 different keys. How we are going to encrypt 3 times 3 different keys? How we are going to do? Here what we are going to do is, first I have given here A. I'll just wrote it down here. First I will give here A. This is my 3DS I'm doing. Okay, so now I have sent it here. I will do my encryption algorithm here. I will send one kind of your key. So what I'm going to do, I will get the cipher text, that is my B. So next what I'm going to do, again this is my encryption. Okay, that you remember, this is my encryption. Next what I'm going to do, I will do the decryption here, because you know I'm going to do the decryption over here. I will do the decryption. Again, I will send one more key. When I will do the decryption, again I will get something, right? Again, I will write here plain text I am going to get here, that is my C. Again, I will do the encryption process. If I will do the encryption process here, I will write here E. Okay, again I will pass my secret key over here, and from here I'm going to get the plain text. That is, if suppose I have given here as X value, and I will get here as my plain text as similarly as X value. So you can see 2 times of encryption, 1 type of decryption I have done. So that is nothing but my, you can say this is 3DES concept. Okay, so now um, so this is all thing, everything is known as this DES. This 3DES is the advanced version of your DES, data encryption systems. And so here the next 3DES is not there in your syllabus, but you can understand the concept. So now moving towards the next slide. The last approach, that is your AES. AES is nothing but advanced encryption system, where we are going to process the data with your 128 bits. Okay, 128 bit of blocks. Here you can see 64 bit plain text, but here you can see 128 bits. And what all are the keys you are going to send? You can send 128, 192, 256 bit keys. And here also it will be useful for your brute force decryption algorithm, and also it can useful for your how you are going to encrypt the data. Fine. So this is all about your network security and the principles of cryptography and DES and AES concept. Thank you.